Good afternoon, everyone. This video is for our class on November 6th. Because I have a conference in Jackson, so we canceled the class meet. But still, I recorded this class, and if you can see it now, that means you're in the right place. So today's class, we want to go over some critical points in Chapter 4 before we jump into Chapter 5. So some clarifications and some highlights, but these are very necessary concepts we need to memorize. So the first thing I want to emphasize is what is economically equivalent. Because we said economically equivalent or future equivalent, present equivalent. We use this term equivalent a lot in Chapter 4. And what do I mean by when I say it is equivalent? So for example, if we have some cash flow from year 1, 2, 3, 4 to 5, and we have some income at the beginning. Let's say it's P0, and the income is $1,000 US. So in this case, we have some money coming in at the beginning of our first period. And we have interest rate, let's say 3%. This interest rate could be the interest rate in our saving account or in your investment plan or your retirement plan, or even just the inflation rate of the economic market. Okay, but there are interest rate there. That's why we need to learn how do you convert some amount of money present to a future or an annuity. Okay, let's go back to this example. Equivalent value of this present value of 1,000. What is the equivalent value? So if we ask you what is the future equivalent of this 1,000 after 5 years, it means still you're looking at this same timeline from year 1, 2, 3 to 5. Okay, but here what you want to do is you want to find out some future amount of money at the end of period number 5. You don't know, but you know it's some future money in the end of period number 5. Okay, and if you convert this future money at year number 5, the F5, if you convert it back to the time 0, somehow you will get a P0 again, right? And if that P0 prime is the same as P0, 1,000, then we can say the F5, no matter what amount it could be, that amount is the equivalent, the future equivalent of the present amount 1,000. This is what we mean by equivalent, economically equivalent. So the equivalent means if you convert, in here we have scenario 1, scenario 2, right? If you convert the cash flow in the scenario 1 and 2 all back to some same time spot, in our case, we convert them to the present time spot. So if in case 1, you convert everything to the present time 0, which is 1,000, because in scenario 1, we don't have any future cash flows. We only have a current cash flow at time 0. So actually, there's no conversion. But the idea is, if you convert everything to the present for case 1, and if you do the same thing, you convert everything in scenario 2 to present time 0. If the present value at 0 in the two cases are exactly the same, then we could say case 1 and case 2's cash flows are equivalent. Okay? And because in case 2, what cash flow you're looking at is the future cash flow F5, so the amount of F5 will be the equivalent future value of the present value 1,000. Also, you can do something like in the third scenario, okay, you're still looking at time from 1, 2, 3, 4 until 5. Okay, but here what you want to look for is the annual equivalent. Annual equivalent means you want to have some annuity cash flows at the end of every period at the same amount, annuity. But if you convert all this back to the present value, some P double prime, and if this value is the same as P0, 1,000, 10,000, then we can say this annuity, this A, is equivalent annuities of that P0. Okay, so for P0, for a present value, you can find its future equivalent. You can also find its annuity equivalent. And the reason why we say they are equivalent is in the 3 scenarios, if you convert everything back to the same time spot, to the 0 times 0, all the present value of these 3 cash flows are the same. That's why we say they're equivalent. Okay? So this is very, very important for you to understand the whole chapter. And the next thing is the cash flow diagrams. We have done some in-class exercises, and I can tell that some of you still don't understand the cash flow diagrams. Well, you don't have any problem drawing the timeline, which is good. So, and you all understand the viewpoint for you to draw a diagram, right? But I do see problems about drawing annuities or distinguish between annuities and present value and the future value. So we have to go over these cash flow diagrams again. So cash flow diagrams will show you how you spend or how you earn money during a timeline. So at what time you receive how much or you spend how much, all those cash flows can be drawn on this diagram. And why this is so important? Because as you can see, or as we have already seen in our classes, we are going to see very complicated cash flows. It's not just a single payment or single income. It's gonna be multiple income or expenditures and even multiple annuities or gradient annuities on the timeline. If you don't understand how to draw this diagram correctly, you couldn't decompose the complicated cash flow to different parts or different components and then integrate them back again. All of this starts from a correct cash flow diagram. That's why we want to make sure everyone can draw it correctly. So, to draw this diagram first, you have to define a viewpoint. And usually, the viewpoint will be given in the problem. And you are going to draw a horizontal line, which is the time scale. So depending on how many years or how many periods in the problem, you are going to draw that many of points on your timeline. And time points are the end of each time period. So we have 0, 1, 2, 3, 4, ... and n. But the 1 doesn't mean it's the first year. It means a time spot at the end of that first year or first period. Same, if it's 2, it means that's the end of the second period. It's not the middle, it's not the beginning, okay? Only 0 is what we call the beginning of the first period. So that's very important. And all cash flows placed at the end of the month. In our problem statements, we always say, you receive some money at the end of which period, or you spend some money at the end of what period. So all the cash flows will be drawn on the time spot. And because that time spot is the end of that period, okay, so all the cash flows will be drawn or will be placed at the end of that period. And again, if you define the viewpoint from your perspective, from your defined perspective, if you're spending money, then it's a downward arrow. If you are receiving money, then that's upward arrow. Okay, so that is the rule you have to follow for drawing this diagram. And here I have an example. That's from our case to buy a car from from 2 dealers, okay? And this is just the case of the first dealer. And here we assume that the interest rate is 8%. You buy a used one, okay, second-hand car, right, at 18,000. And every year the machine needs 34,400 to operate and maintain. At the end of the 8th year, you can trade in or sell at 2,000. So here are the cash flows. And the first thing you're gonna decide what viewpoint to use, okay? And we said it's gonna be given, so let's add one condition. So use your point of view. Okay, so you are doing this and you are spending 18,000 at the beginning to buy second-hand car, and you are spending 34,400 every year to maintain and to operate that car, the machine, and you are going to sell that so you can receive another 2,000 in the end of the 8th year. So that's what we say your viewpoint, okay? And now the first thing is, because there are 8 years, right? So your timeline will be from 0 to 8. 1. So 0 means the beginning of the first period. And 1 means the end of the first period. In our case, the period is year. So it's gonna be first at the end of the first year, the end of the second year, the end of the third year, the end of the fourth year, the end of the fifth year, the end of the sixth year, the end of the seventh year, and the end of 8th year. Let's get rid of this extra length. Okay, that's your timeline. And we said at the beginning, you spend 18,000. So that's the money going out from your pocket. You're losing that money. So that's downward arrows. So you're gonna have downward arrow at the beginning. The amount is 18,000. So you're gonna label that near the arrowhead. Sometimes if you don't have much space, you can write it as 18K. Okay, but you need to have that dollar sign. And at the end of every year, you're gonna spend 34,400 to operate and maintain that machine, okay? So that's also the money out of your pocket. So that's downward arrows. And it's every year, so that's gonna be a downward arrow at the end of each year. Okay, and they are annuities, right? They are same amount, so it's the same length. At the end of every year, even include the last year. So the arrows at 8. And the amount, you can write it as A because it's the same annuity, equals to 34,400. And another cash flow is at the end of the 8th year. And at that time, you are done with this machine and you decide to sell it or trade in. And then for that trading, you can receive 2,000. And that's the money coming into your pocket. So it's a upward arrow. Okay. And we said we want to draw the length of the arrow to the scale, which means if you have a larger amount, that length will be longer than a smaller amount on your diagram. So you can see the arrow length of the 34,000 is much longer than the length of 2,000. Okay. And another thing is you want to label out what is the interest rate. In our case, it is 8%. If you write it like that in the middle of the timeline, that means this interest rate stay the same. And we have seen some case where the interest rate could change over time. In that case, you're going to write those interest rates right on each period. Okay? So this is how you draw this diagram. And I want you to practice a lot. Use our examples in classes and try to compare if your diagram is the same as what we have seen in the class. Okay. The third thing I want to point out is about this example. Remember, we saw this example in the class. We said at the beginning, you borrowed 100,000 from the bank. And you plan to pay as annuity, so in the end of every year, you want to pay 10,000. until the year 20th year, okay? Until 20th year. But in the end of 21st year, you want to pay a lump sum to finish this loan. You want to pay off everything. So what is your F? How much you need to pay in the end of the 21st year so that after all these annuities, you can pay off this 100,000 debt. Okay, that's the case. And we said, assume that the interest rate from the bank is 8%. All right. So, in the class, I remember some students asked me, why after you paid 10,000 each year for 20 years, you still have to pay a lump sum, F? Isn't the 10,000 every year times 20 is what? 200,000. Isn't that big than what you have borrowed at the beginning? What's wrong? If it's bigger already, why do you still have to pay a lump sum at the end of the 21st year? Well, this is not true, because it is not just simply time 10,000 with 20. You have an interest rate as 8% going on there. So in the end of the first year, your 10,000 is already not 10,000 at the time 0. It's smaller. And at the end of year 2, your another 10,000 is even smaller if you convert that to the present time 0. Because of the interest rate, your 10,000 payment for 20 years won't be 200,000. And actually it's gonna be smaller than that value if you are looking at this at the time 0. Okay? So let's just do the calculation and see if I'm correct. Okay? So the story is, you borrowed 100,000, and in the end, so you borrowed 100,000 at time 0, okay? And then you pay annuity for 20 years, A for 20 years, and you need to have a lump sum at 21st year, right? And that's your payment. So for a bank, what they want to do is at least what you pay equals to what you borrowed at their interest rate. Okay? Otherwise, they're going to lose money. They're not charity. They won't just lend you the money without any interest or even lose interest. So these two have to be the same. Okay? And that's what we said, equivalent. Remember when we said equivalent? That means if you convert the cash flow back to the same time spot, it has to be the same. So the first case is you borrowed 100,000. That's your P0, right? So your P0 is 100,000. That has to be the same with if you convert your payment plan, annuities for 20 times, a lump sum in the end of 21st year. If you convert all of this back to time 0, you still have your P0 prime will be the same as P0. That's what we say is equivalent, okay? So, and now let's say, how do we calculate the P0 prime? The P0 prime will be, first you convert all the annuities back to time 0. And look at that annuity, okay? This annuity is 20 payments. Okay, so from 1, 2, 3 until 20. So you have 10,000 going on. And the first thing is you convert these annuities back to time 0. So that's your P0 prime from the annuities. And another cash flow is to convert this future lump sum back to the time 0 too. So you're gonna have your P0 prime from what? From that future. Okay? And then what you have, so first, how do you convert these annuities to time 0? We can use the formula or the factor method. And to use that method, you have to understand what is the typical cash flow, right? Our typical cash flow for the annuity is we have payment starting from 1 until year end. And here, because we stop paying at the end of 20, right? Which means our end is 20, it's not 21, okay? So, and we want to have the present value. So it's to find P given A at interest rate 8%, number of periods, because the annuity only, it only goes to the year 20. It doesn't go all the way to year 21. So your N is 20. And of course, you want to use the A to time with this factor. Plus another cash flow conversion from the future cash flow. So you wanna find the present value of that future value at interest rate 8, number of years, because that's in the year 21. So you have to jump 21 times to the present. So it's 21. Okay? And now let's calculate. Okay, let's go back to the top so we can have some space. So everything continue. So the A is 10,000, right? Every month times that factor. So PA, table 8%, row 20. So this is the table of 8%. And we said PA, column, row 20, row. So this is our factor, 981.81. So it's 10,000 times 981.81, right? Plus a future value you don't know, and it's fine, times a factor. That factor is PF, P/F, and 8%, 21. So still, you're looking at the 8% table, but it's PF, P/F. So that's this row, this column, and then row 21. So this is your factor. It's 1987. 0.1987. Okay, so now what we have is actually an equation. It's 100,000 equal to this term. And in this equation, you only have one unknown variable, which is f. So it's easy to solve for this f. So your F will be, okay, 100,000, right? And you move this to the right. So it's gonna be 100,000 minus 10,000 times 981.81. Look at this. 10,000 times 981.81. Isn't that the cash flow? Isn't that the 2010K cash flow converted to present, right? And you see, it's not 10,000 times 20. It's 10,000 times just 9 point something. So all the cash flows in the future has to be discounted if you convert them back to the present. You know what I mean? So that's why even though you pay 10,000 for 20 times, you still don't pay off because there is interest rate, so everything got discounted. Your 10,000 after 5 years is not already 10,000 at present. Okay? Okay, let's continue to calculate. We want to solve for this f. So, and then we still need to divide this by the factor. And let's say, how much do we get? So 100,000 minus 10,000 times 9.8181. 1819 divided by 0.1987. Alright, so what you have is 9154.50. Look, this f is bigger than 0, right? It's just like what I said. Although you paid 10,000 for 20 times, because of the interest rate, you are not paying off. You still owe some amount to the bank. And that amount is positive, which means you still have to pay that amount. Okay. Then let's move on to the next stuff. The cash flow diagrams for typical problems. Yes, cash flow diagrams are super important. You have to know how to draw them. Especially you have to know how to draw the typical cash flow diagrams, right? For different types of problems. Here, in this chapter, we have learned the PF problems. What does it mean? The PF problems means you want to convert some present cash flow, you want to convert that to future, okay? Or you want to convert some future cash flow back to the present. That's what we mean the PF problems. And for PF problems, the diagram is pretty easy. You can convert any cash flow at any time back to present or to the future using the formula or the method or the factor methods. The only thing you need to worry about is how many jumps you make. Okay? So it depends on where you have that cash flow and where you want to convert it to. If you want to convert the cash flow from 0 to n, then you jumped how many times? Of course, n times. If you want to convert that P to year 2, then when you use the formula or the factor method, your n will be what? Will be how many times you jump. So in that case, you will jump twice. So your n will be 2. The same case, if you convert some future value back to 0, from n to 0, how many times you jump? N times. And that n will be the number of periods you use in your formula or method, or factor method. The same thing, if you want to convert that future value back to time 3, and then how many times you jump, you can calculate, you can count, right? So if you calculate that jump time will be n minus 3. And the n minus 3 will be the number of periods you use. Okay. Another set of problem is the A problems. So A problems is more complicated because we got something new called annuity. So between, from 0 to 1, 2, 3, to n, right? You're going to have some annuities. They are the same amount, starting from time 1 until time n. Okay, that's your typical cash flow. It's not starting from time 2 or time 3. Okay, it's from time 1. All right, and that's your annuity. So you can convert all these cash flows back to present time. So that's to find the P given A. Or you can convert everything to the future. That's to find F given A. Okay? And of course, if you have some cash flow at the beginning, and you want to find the annual equivalent of that cash flow. So, what does it mean? You want to find some annuity numbers which you don't know, but if you convert everything back to the present, you're gonna have the same present value. So that annuity will be called as annual equivalent of that P0. Okay, and you can also do the same thing, say if you have a future value, and using the same way, you can also find its annual equivalent. And that annual equivalent will be, if you convert all of them back to the future, somehow you have the same future value as Fn. Okay, so that's the A problem. And you need to understand the A problem, the diagram is cash flows, the set of cash flows, they starting from 1. Okay, starting from 1. And we talk about deferred annuities. A deferred annuities means the annuity, the annuities, the cash flows, it doesn't start from 1. It starts from somewhere later. Sometime later, you don't know, it could be 3, 4, but it starts from sometime later than 1, okay? And to use the formula, you have to know what is J, okay? So say if you have a cash flow of deferred annuities from 1, 2, 3, 4 until n, and then your cash flow starts from year 4 until year n. That's a deferred annuity because it doesn't start from year 1. But what is your J in this case? Your J will be 3. Okay? And why? Because compare these two cash flows. In your typical diagram, your cash flow starts from J plus 1. So, which means 4 equals to J plus 1, right? And then, if 4 equals to J plus 1, then J equals to 3. You have to practice a lot, so when you use the formula, you can quickly tell what is J. Okay. And another special diagram is the gradient cash flows. Remember, everything starts from year 2, the end of year 2. Okay? It's not from 1, it's from 2. And if you want to use the formula or the factor method given, you have to make sure your cash flow starts from year 2. If not, you have to do some conversion. But if it's geometric sequence cash flow, it still starts at 1. Okay? And you have to, distinguish all the different typical cash flows, where they start, and then if you can use the formula or the method directly, or you have to do some conversion to do it correctly, you really have to memorize, okay, how to draw these typical cash flows. All right, and the next stuff is the nominal and the effective interest rate. So we wrapped up very quickly about this part, but still it's very important. So first you have to know the concept about nominal interest rate. The definition is when the interest period is less than 1 year, the interest period, how often, how long you have to calculate your interest. That's the interest period. So if you compound your interest or calculate your interest every month, then your interest period is a month. And if you do the interest calculation every day, and then your interest period is a day. So if your interest period is not a year, it's less than 1 year, then a customary way to quote this interest rate on an annual basis is nominal rate, because everybody likes to say something on an annual basis. That's just a customary rule in the world of the economy. Okay, so all the banks, they decide, okay, no matter how often you compound your interest, we all say something on an annual basis. Okay, that's what the nominal rate is. But here, based on this definition, you have to know the nominal rate is just a saying. It's not the actual interest rate per period. Okay, because based on the definition, your compounding period is less than 1 year. For example, if the interest rate is actually 6% every half year, which means you have to compound your interest every half year at 6%. Then, what commonly be used is the nominal rate is gonna be 12%. But you always have to describe how it's compounded. So 12%, but compounded semi-annually. Okay? If you are given nominal rate is 12% compounded at semi-annually, then you automatically know the interest rate per compounding period is 12% divided by 2, because every year you have to compound it twice. So if another example, if the interest rate, if you are given nominal rate is always an annual rate, okay? You don't have to say that all the time. If somebody said nominal rate, it means it's annual rate, okay? So nominal rate is 12% again, but compounded daily. Wow, that's very extreme. Then what is the interest rate per period. If you're compounding that daily, which means your interest period is day, okay? So in a year, you have to compound that 365 times. And then your interest rate per period will be 12% divided by how many times you do the compounding. So it's in a year, okay? So it's 365 times. And now you can do the calculation. So 12% times 365. So actually your interest rate per period is 0.03% per day. Okay, now let's just memorize this, okay? So if you use, this is another example, you have a credit card which is, okay, APR 15%, and this APR is the nominal interest rate, okay? If you use this card and you used 100 at the beginning of a year, and you have to pay, you have to pay it back in the end of that year, how much you're gonna pay? Okay, is it 115? Okay, so if you know nothing about this nominal interest rate, of course you're gonna say, APR is that's interest rate per year, so in the end I'm gonna pay 15% more, so that's gonna give you, you spend 100 and you have to pay 15% more, right? So that's gonna give you 115. So I have to pay 115 back to the bank. Well, after you know what is APR, what is nominal rate, that's not true. You're not gonna pay 115, you're gonna pay more. Why? Now let's do the calculation. So we said 15% is a nominal rate, and we assume, okay, we need to add a condition. Assume it's compounded daily. Well, you really have to go back to check your credit card manual. We have a user manual, right? And in the user manual, there will be a fine line telling you what is the compounding period. Go back to check it out. But here, let's assume it's a compounded daily, okay? So if it's compounded daily at a 15% nominal rate, what is the actual interest rate per period? 15% divided by how many times you compound? A year, right? So if it's daily compounded, then a year you have to compound 365 times. And then your interest rate per day will be 15% divided by 365. And that will give you 0.041096. Let's just save as much as we can digits, okay? So that's your interest rate per period. And remember, we have a formula to calculate your interest. If you compound that interest, right? And that formula is your principal times 1 plus interest rate per period, right? To the power of n, number of periods, and minus that p, right? So here, the P, the principal you borrow, is 100. 1 plus your interest rate per period is 0.041096% to the power of 365, because you compounded that 365 times a year, minus 100. Okay, let's see what we get. So it's 16,179891. Let's say it's $16,118. That's your interest. And then the total amount you have to pay will be your interest plus your principal, right? So it's gonna be 1618 plus 100, which is 11618 US dollars. You see that? That's the actual amount you have to pay, and it is bigger than what your first thought is, 115. Okay, and now let's introduce another concept. So until now, we have used the nominal interest rate, which is a fake interest rate. It's just a common saying. And we have used the interest rate per period. That's a real interest rate you use every period. But your compounding period is less than 1 year. So that's only the interest rate per day or per period. It's not per year. But if somebody say, I still want to check or look at this case on a yearly basis, what does it mean? It means if you are still looking at it on a yearly basis, you are look at the timeline from 0 to the end of 1 year, instead of the timeline from 0 to first day, second day, third day, to the end of 365 days. You see, these two timelines are the same length because they are all the same year. But the second one is to look at it on a daily basis. And that is the actual calculation. But somebody still wants to look at it on a yearly basis. Okay? So somebody still wants to just to compound it once. And you have some present value of 100, right? And you want to just compound it once, and you want to get the same value as the 116. This is your future of 11618. So somebody wants to find an interest rate, I prime. And that I prime is an annual interest rate. And somehow if you use that I prime percent, you can convert 100 to 116.18. That's the idea. That's how we say we look at the same case, but on a yearly basis. Okay, so we count it once a year. And you already know your future value is 116 18. And somehow you want to convert your 100 by some annual interest rate to after the end of 1 year, and you still want to get the same future value, 116 and 18. So what you're going to do is to use the P times 1 plus I% to the power of 1, right? That's the formula. And you have 100 and 1 plus I%, that's I% prime. So now if you calculate your I%, that's gonna be 16.18%. And this 16.18% is your effective annual interest rate. For this nominal interest rate, 15% compounded daily. So now we have learned 3 concepts. One is the nominal rate. It's a fake rate. It's just a saying. Second is the interest rate per period, which is actually what you used for calculation on a daily basis. Okay? Third is the effective annual interest rate. This interest rate is just to look at the same timeline, same cash flow, but you want to somehow convert it on a yearly basis. But all of these are equivalent because you can, no matter what basis, what period basis you use, the future equivalent value is always the 116 and 18. Okay, and that's why we say interest rate per compounding period and the nominal annual interest rate and the effective annual interest rate. There are 3 different numbers, but if you convert the cash flow by these 3, they all give you the same future equivalent. And as you can see, the way you calculate the effective annual interest rate is really complicated if you do this calculation. So there is a formula to use. And that formula is I equals to 1 plus R over M to the power of M minus 1. And here, the I is the effective annual interest rate. Okay, it's just to look at this cash flow still on a yearly basis. And the R is the nominal annual rate. M is the number of compounding period per year. So the M could be different. If it's compounded daily, M will be 365. If it's compounded half year, the M is 2. If it's compounded quarterly, the M is 4. Okay? If it's compounded monthly, the M is 12. You have to know how to calculate the M. All right? So if you do the same example, but you just use the formula, so it's more straightforward. The formula said the effective annual interest rate is 1 plus R over M to the power of M minus 1. And here, R is 15% because it's compounded daily. So number of periods a year will be 365 to the power of 365 minus 1. Okay, let's see. It's 1 plus 15% times 365 to the power of 365 minus 1 it's 16, 18%. You see that? It's the same as what we calculated here. Okay? Alright, so that's it for today. And we will start to learn chapter 5 in the next week.